Okay, we'll move on to binary multiplication. Okay, so the rules are very similar, and the multiplication 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. So this is what we're going to do. Okay, so you take, we're trying to multiply 5 into 6. Okay, that's what we're going to do. So here you have to take each of this bit and you need to multiply with all these things. 0 into 1 is basically 0, 0 into 0 is 0, 0 into 1 is 0. And this is called as a partial product. So that means this is called as the first partial product. That means you have taken 0 and you multiplied with all these 3. So this had given you the partial product. Now you need to take 1, then you need to again multiply with these 3 things. So 1 into 1, 1. So you have to leave this place and you need to start writing it from here. Okay. So 1 into 1, 1, 1 into 0, 1 into 1, 1. So now again you take this. So again you leave this space. You need to shift it. You have to keep shifting 1 bit to the right. Okay. So 1 into 1, 1, 1 into 0, 0, 1 into 1, 1. So now you just need to add all these things. 0 will come as it is because it didn't have anything. 0 plus 1, 0 plus 0 plus 1, 1. 1 plus 0, 1. As it is comes like this. It's 1, 0, 1, 1, 1, 1, 0. 5 into 6 is 30. So the representation of a decimal 30 in the binary is 1, 1, 1, 1, 0. Is that clear? So this is how the binary multiplication will be performed by your computers. Is that clear? So this is how the binary multiplication happens. Somehow the miscalculation of subtraction didn't go well. I think I'll look into it. I'll come back to you guys. Okay, there is some step missing in between. Maybe I had overlooked it. That had created a chaos. But sorry for that, and I'll look into it. Okay. So now you guys understood the binary multiplication, binary subtraction. We'll talk about it. Binary addition. Correct. So now these are the 3 major operations. Correct. The addition, multiplication, subtraction, and division. Division, anyways, we didn't talk about it. That's okay. But these are the 3 major operations which your computers usually perform. So that's the reason we talked about these 3 important operations. So now, if I want to convert the symbol into the ASCII number, then to the binary number, then what should I need to do? First, I need to take the symbol. This is a symbol. Okay. Now, I need to get the decimal number from it, decimal ASCII number for that. So the plus is a symbol. So what is the decimal number for this? ASCII number for that? 43. So where do you get this? In the ASCII chart, correct? So if you go to the ASCII chart, the plus is represented as 43. We looked into it in the very beginning sessions, correct? So plus is represented as 43 in the the mapping for the number mapping for plus is basically 43. Now convert that into binary. This is how it looks like. The same way with this, correct? So CHEF. So if I want to convert this, C is a symbol, H is a symbol, E is a symbol, and F is a symbol. All these are the ASCII characters, correct? So they are all represented in the binary. So you need to take each of this character, take the respective mapping, decimal number mapping, and convert that into binary. This is how it looks like. And ASCII characters are always 7-bit representation. You guys need to remember this all the time. Okay, it's always the 7-bit representation. It's going to be very important. 7-bit representation. It's not the 8-bit representation. Okay, so but if you go to the granular level of your computer, what is the most granular unit you guys see in terms of memory units? The byte, right? We've been keep talking about it, right? 1 byte is how many bits? 8 bits. So now, but how many bits you have? So now there is 1 bit remaining, correct? That will be now padded with 0, as simple as it is. Whatever the bit that remains empty, that you will just put it as 0, as simple as it is. That means it doesn't have any value. Are you guys following what I'm saying? So the most granular unit, memory unit of a computer is byte. How many bits is 1 byte? 8 bits is 1 byte. So but how many bits you get for your ASCII character? 7 bits. Now whatever the remaining bit you have, 0. It doesn't have any value. Are you guys following? So the representation of CHEF, that means if you are trying to store CHEF into your memory, this is how it looks like. Each of this character is given with 1 byte. 1 byte. Each of the character has been given with, each of the symbol has been given with 1 byte. And it exactly takes 7 bits, and the last bit is 0. Are you following it? So anything that you try to represent, it has to be represented ultimately in the form of bytes. If you are trying to represent 1, let's say 1, okay, if you are trying to represent 1, how much, it still takes 7 bits, correct? So 0 0 0 0 0 0 1. Are you guys getting it? But all these zeros doesn't have any value. Am I right or wrong? But most granular memory unit is byte. So that's the reason why, even though unnecessarily we are giving 7 bits for 1, we still need to put them as zeros. Because if you go to the granularity, that means the least granular thing, unit is byte. And byte is represented as 8 bits. That's the reason why, even though you need 1 bit to store 1, which is just 1, you're still giving it 7 more bits, because computer represent everything in the form of bytes. Even though just 1, to represent 1, it requires only 1 bit, correct? Because rest all are zeros, it doesn't have any value. But still you need to represent with zeros, because computer will store everything as in the form of the bytes. It's going to be 8 bits, by the way. Okay.